We will wait a little bit more for everyone to settle. Okay, ready? So the food was good, everything okay? Praise the sponsors for the food. Can I get an amen for the sponsors? Okay, so if everyone is paying attention, the next presenter is Marton KodoK. He will present to us Vertex AI, unified ML platform for the entire AI workflow on Google Cloud. So please, Marton. Okay.
Hello. No. Good. So hopefully this microphone will be a bit better, and I will stand here for the camera, but I see everyone, and I'm very happy to be here. Can we have the slides? Good. I am not a rock star, but I need to get along with this microphone. Good, so we are here today to actually talk about Vertex AI. Vertex AI is part of the Google Cloud Platform, and it's a relatively new product. It has a former name, AI Platform. We will see what this platform is for, and in order to cheer up after the lunch, I will do a bit of quiz with you. So who is here a machine learning developer? Great, I expected a low number. Who is a software developer? Great. Who runs Python? Okay, better. Every year, better with Python, Romania, so that's great. Good. Is there anyone who runs machine learning in production? Yes, sort of. That is a strong yes. That is a strong yes. At least you have thought that. I don't know. Okay, good. So, agenda about Vertex AI. What ML training job types? So I brought you a beginner and an introductory level of this Vertex AI talk in order to get the sense of the tool, how to build, train, deploy. We are see briefly pipelines, and if we have time, we will see how we adapt to changes, because kicking a machine learning job is also thing to actually launch based on certain actions into the cloud. My name is Marton KodoK. Bine v-am găsit. Sunt din Târgu Mureș. Okay, yeah, I need to do this phrase usually. You can find me on Stack Overflow. I crossed the 200,000 reputation points, and I'm still the third one. So there are actually two better Romanians who do a lot more answers on Stack Overflow. Find them, ask them to come to DevFest and present their journey, whatever there is. What I want to say is that you should build up your Stack Overflow reputation by answering. That's how I did, and it's an amazing job to actually do so. I'm appointed GDE, Google Cloud Champion, whatever programs I'm part of. You can find my articles on Medium. I deactivated the paywall, so you can read them. There are nice articles. I usually blog about things that others don't cover. So I have few articles, but they are very niche on the topics that I publish it, mostly about Google Cloud. Let's see Vertex AI. Vertex AI is a managed machine learning platform. It means that you don't need to fiddle with infrastructure. You just set up the billing, the credit card, and the platform does the job for you, and you don't need, let's say, a sysadmin to actually do all the machine learning stuff. It's also for developers. So it's not for sysadmins, it could be for data scientists, but mostly for developers. It can run ML experiments, which means that if you happen to be a data scientist, you could run 20, 30 times an experiments for it. And my favorite as a developer is that you can deploy models like a REST service. And I need to ask the guys in front of it to lower the voice there, but they don't observe me. So essentially, whoa, that's strange. Essentially, my favorite, as I was saying, is to deploy the REST service and to have models consumed as an API, which eases my life for it. Let's go next. If I want to provide an overview of the system, I need to name the three majority of models that you can run on Vertex AI. And first of all is AutoML. We will see what this means. You don't need any background for this. Custom models, as the name suggests, you put together everything, your code, your containers, your data sets, everything you need to put together. It's, let's say, the advanced level. And recently, BigQuery ML, which offers you like 20 models based on tables, based on data that you keep in BigQuery, accessible also through Vertex AI, and has benefits like batch prediction and other more things. So when you have the data and the models you are building, and you have a Vertex AI model, and itself everything is in the Vertex AI system, then you can deploy to an endpoint and you consume it. I put it a generic computer here. It could be a service that you write. You need to write the service. You could deploy also to on-premise. So it's not something that you need to run in the cloud. You can run exactly where your app right now it is. It could be on-premise, Amazon, where it is. You can just use this Vertex AI platform. As I said, serverless, you don't need sysadmin. What I want to mention is that instead of thinking in the function as a service model, you think here as a model, as a service model. That's the most important thing from this slide about this. What's included in Vertex AI? Vertex AI is a very complex product. And essentially, this chart shows almost everything which offers. And I briefly will go through it because I will repeat and base my slides about this. So we have from data readiness, feature engineering, training, model understanding, also model monitoring management, different timelines in the machine learning perspective. You don't need, as a developer, you don't touch every step of this. If you are a data scientist, you touch everything. Then we have the three levels, AutoML, BigQuery, and custom models, which are different sections how you prepare the machine learning objective that you target. Then, essentially, you have data sets, which is based on data set. There is a training process, you have a model, you have an endpoint, you have a prediction of it. The rest, usually, there is connected with the pipeline, and you have access to notebooks, deep learning environment, and other artifacts and other elements in the Vertex AI system. Let's go to part 2, AutoML objectives. Essentially, there are 4 categories here: image, tabular, text, video. Each contain at least 4 different objectives that's pre-trained. So that means that you as a developer, you need to create only the data set if you want to do, for example, image classification. What I like here is that the multi-label image classification is a fantastic thing because it already has all the knowledge power, what Google knows about the internet, and it automatically labels you certain objects from your images without adding data to you. So it can name the Eiffel Tower and different things for it. If I want to create a flow to actually build out an image classification prediction, I have on my computer some images which I place on cloud storage. That's the S3 of Google Cloud for others who are Amazon-centric thinking. Then you need to label it. I will show that how it works. Then you have a data set. The data set contains, let's say, 3 parts: training, eval, and prediction data or validation data for that. And then you have the Vertex AI endpoint where you feed the new information. The new information is here an unseen image before, and it will predict. This is the interface, how it looks, and it's created, and it's very rich on the Google Cloud Platform. You are able to actually visually upload images, and if you see, not sure in the back seats, if you see here, these are the labels, and you can classify images here for the job itself. You have here, I mean, in my example, 600 images for different categories of flower as well. Different objectives, like for example, detecting an object on an image is also a second objective that you can do in Vertex AI. It means that you upload an image and you have even a UI tool pre-built in the console to highlight the object that you want to train for the model itself. This is all possible by JSON annotation. So if you are a programmer who prepares this off-site or off Google, you are allowed to do that. That way, you need to upload for each image a JSON line that describes the coordinates for this kind of jobs. And I can continue for the rest of the models as well. This actually how you create the AutoML models. And if I go further, there are tabular data. And tabular, it means for you from database, from columns. And it's very helpful because a lot of you think you have a project where you could, for example, do a forecast job, or you could have a regression or a classification that you already can run. And going back to the first question, if you have a machine learning in production, it's actually time to figure out if you have a tabular data or an image already ready, and you can do your first model to actually go in production with any machine learning objectives. Text, we already seen today a presentation how to match and extract AI work from questionnaire, and that's also a good thing. Google had actually took this to a different level, like you could give them a PDF or a photo of a bon de casse, folosesc, receipt slip, and it detects automatically information, mostly without training, because it uses also community and also the power of the Google. So a lot of information, you will be amazed that it works out of box for you. If it doesn't work, it means that you need to prepare the data set. The model is offered for you, but if it doesn't work, it means that you need to work on better data set. Good. And also video, yeah, and I can continue on fully on this. I will skip this. What's data labeling here is that if you don't have the ability to label data, you can pay them. They have a force, like a human force, that will automatically, based on your instructions, label the data. So example, if you want to upload t-shirts and you want to highlight the company logos on the t-shirt and you don't have this information pre-labeled, you can pay directly on Google Cloud without knowing who is the person, who is the human force that does the labeling for you, and it's offered for you as a service. Part D. Once we have the data set, we can build, deploy, and train the models itself. Once the model is being trained, usually, let's name it, it takes hours. So essentially, this is an AutoML job. You don't need to provide a machine. You don't need to provide a container. You don't need to add Python code. You just hit the button, train, and usually it runs for, let's say, 6-8 hours. And it will notify in the email and in different API calls that the model is ready. Because from data set, the training process result is a model itself. As it's noted and depicted in this picture, from dataset training, you get the model itself. In a nutshell, for all those who are database-centric, you get a table. But not the table itself, you get the model. So you have the model registry to use the terms that the Google Cloud Platform, and there the models are listed. Training, I put it here to have AutoML and also custom training, because I already told you mostly about AutoML, where you don't need to add your own custom code. But Vertex AI actually lets you to do your own machine learning code as well and your own training. And you can use here pre-built containers. So if you are in some frameworks that are supported, you can get the sysadmin work already offered by the containers. If you have the full admin team, you can have built out also the container and use your own container. Essentially, these are the platforms that are offered by pre-built containers. So if you, for example, let's name it, you find a model posted on GitHub, or you find the process how to build a model on GitHub, and it's among these frameworks, you can build and train that model which you found on GitHub based on your data. So it's essentially that more and more models and processes how to build model are published to GitHub, but you need to add the data. Why it's important, why they don't publish data? It's license issue. So usually they can publish the pipelines or the process, but they don't publish the data set for it. If you are building the data set or obtain the data set, you are able to rebuild all the models for you. And it works really nice. We have done this, and we have gone into production just by taking models, adding our sets of images, adding our sets of tables to it, and seeing the results as much as we could. I don't speak in prediction here, I mean in percentage, but it was a good acceptance to actually go into the production for it. Once you have the model ready, you want to do something with the model. You can deploy it to an endpoint. Endpoint, it means a REST service. That REST service, you have there a scalability. You can set number of nodes. You can go, let's say, viral with it. You can go scalability here, but you need to pay serving those models itself. As I mentioned briefly already, HTTP endpoints are there to predict rapidly and reliably for you. Essentially, you can implement in your application an URL and the respective authorization to it in order to predict based on your input. The input could be an image, it could be a JSON, or a table row itself. Endpoints. Yeah, there are different options here. I need to mention that you have traffic splitting options, so you can have, for example, 90% for version 1 of the model, and when you build a new model, new version, you are able to set a 10% traffic to try out the new model, and you can have also pipeline automation that if the 10% yields better results than the old model, you can promote the 10% to be the new version of it. So you have all the mechanisms that you expect in the cloud situation to be there for you. That's why it's called a unified ML platform, because from the data set to the training process to deploying and scaling the service like it was a website or scaling like it was an API service, you are able to do so. And in the end, you can evaluate, monitor, and retrain. I won't go deep in this because this is much more data science work. Essentially, you have visual optimization, AI accelerators, explainable AI in order to see how your model is reacting to your data. And some options of that provide a reference, for example, like from the images you have uploaded, which section of the images provided you the most knowledge to detect the label of the image itself. And if it's, let's say, it's not in the part that you want, it's off, you can actually work, as I mentioned, on your data set. So always, machine learning problem is getting a better data set. Not the pipeline, not the training, getting the beginning a better data set. What if tool? These are tools that lets you actually decide how different versions of models are actually working out for you. These are tutorials and demos for it, and mostly for the basic models, logistic regression, classifications, are YouTube tutorials to set up these tools to actually see some feedback, like how it's performing this model. Good, and let's see how we are with the time. Good, so part 4. All this is good if you run in iteration, because machine learning is an iteration job. And here comes to the story that machine learning pipelines arrived to the cloud at a time when everything it was automated. And for machine learning, we instantly got ML ops. So we got pipelines to coordinate. Yeah, I was aware of this issue. We got pipelines to coordinate everything. So what a pipeline is actually connecting all the dots for it. And it's easier to set up. And you should not think of pipeline for something sysadminish. Pipeline is for data developers and managers, because first of all, I need to convince my managers and my team leaders to actually, let's create a pipeline. And it's hard for doing so, and I always have this information for them, that we can orchestrate as a process, we can adopt MLOps, and essentially, in the developing step is independently, which means that we could have different teams who actually work some on the data set, some on finalizing some parameters for the model, some for scaling and serving and integrating on the model. And these could be different teams in the team. Some could be external to your team as well. But all the process lets you to build out the pipeline, and if one of the elements is changed, the rest of it is not affected. And what's not written clear is that Vertex AI caches the elements of a pipeline. So essentially, if you don't change the very first element, only the 5th element, the 1, 2, 3, 4 are not run again. They are cached, and it's extremely fast to actually develop it. Otherwise, you could, for example, wait 8 hours for retrain jobs. But it's not the situation here. So what is MLOps? It's continuous delivery and automation pipeline for machine learning systems. I have a set of presentation about pipelines. It's a different specific talk where I go into the details, how to set up a pipeline, what the elements of the pipeline. You can check out the slides on SlideShare. And also I have videos about this presentation at Voxed Days, for example. I presented about this process. In a nutshell, this may sound complicated, but essentially there is always a manual process. The manual process then becomes a level 1 process. Level 1 process is where you get a trained model, you have a prediction service. But why we call it level 1? Because based on new data, the automated pipeline is being triggered. So that's why I say MLOps is first level of automation. When you have new data, the pipeline automatically clicks in. Level 2 automation is when you do a commit and you actually change code itself, not the data itself. Let's name it. You are a developer or you are a data scientist, and you figured out a better hyperparameter or a better code that builds a new model. You commit that code. That triggers the pipeline. So this is level 2 automation. I don't ask the room, but last time when I asked the room in Luxembourg, most people are in level 1 system, so they have pipelines based on new data. They still don't automate yet based on new source code, which would mean that the developer works on, let's say, office time. In the end, at 5, 6 p.m., when it does the commit, overnight, rebuilds the machine learning model because it could take 6, 8 hours, depends on the model complexity. And by next day, they come to the office, they evaluate the yesterday works, and so on. The company needs to support this because it's not cheap to run a machine learning model and build overnight. So they maybe do it only once a week, and so on. just a basic example of a pipeline. So you have the data set, you have a training operation. Essentially, this is, let's say, the model artifact. This is the model. Based on that, you have an eval phase. And in the eval, you as a developer set a threshold. You could set that if the model is beyond, I don't know, 90%, you go and deploy it. So you could have here a condition deploy, which means that it creates the endpoint. This is the endpoint itself, only when the percentage and the threshold is met by your system itself. How you do that? Essentially, this is the code briefly, because functions, individual functions are not laid out. So essentially, this is the dataset create operation. This is the training operation. Then we have the evaluation, and we have a condition. And then we have here the endpoint itself. This creates, let's say, a REST endpoint. And this other code section actually attaches the model to the endpoint itself. These pipeline calls are developer-friendly, usually 50 to 100 lines of code. You have plenty of examples of it on the internet. Other workflow of these pipelines is when you build a reduced model for mobile use. So you could have a pipeline to build out a full-blown model for server-side use and a reduced model to build out for mobile use, and you use the pipeline to deliver both operations itself. And finally, the fifth part, we could imagine that we have a pipeline. We could imagine that we have a data set that produces a model, that produces, let's say, it's deployed to a REST service, and then we want to actually react and do automation of it. And we have three situations in the Google Cloud, based on schedule, based on code base itself, and based on changes on data. Essentially, these are three different products in Google Cloud. Who uses this? I want hands. Great. Very few hands, so you should try out these products, because these are great products itself. Cloud Scheduler is just a scheduler, like a cron job. It does amazing things. Cloud Build, it builds out Linux commands or pipelines, but essentially, let's name it shell automation or a bit of DevOps thing. But it's interesting to actually use for a lot of situations. Even Tark, relatively a new product, it sees everything in the cloud, logs, events, and it observes it. And you can hook and observe and do things on it. So you can fully automate the code for whatever you run. One of the scripts left a log, even Tark can be there and pick that up and deliver an event. I've seen that label in the code. I need to alert, and I need to turn on, I need to create something, and so on. Good. In the final, as an Vertex AI is an enhanced developer experience. It has all the tools to run machine learning jobs, mostly for developers, and it has the complex tooling for a data scientist to actually do experiments. By experiments, I mean to create 10, 30, 50 models and finding the best and better models for that. You are building with groundbreaking machine learning tools that power Google, especially for AutoML, where you don't need to create your own model. You have the ease of the life for a data scientist because it provides functions that are developer or sysadmin-ish, and it complementary help them. And of course, you have GitHub-style delivery with Cloud Build. So essentially, only a commit could trigger a new pipeline, and next day you could see the output for it. This was my presentation about Vertex AI. I'm super happy to be here at Craiova DevFest. Hopefully you like this presentation. You can follow me on Twitter itself, and you can find slides about all or similar presentation on SlideShare. I leave this slide a bit here in order to have photo of it, because I see a lot of people taking notes, digital notes usually. If you have any questions, you can ask, Or otherwise, you can find me at the back tables just before the drinks.
If you have questions, please step forward and ask them in the mic. No?
Yeah, I have a question.
Sure, please.
You can use this mic as well.
Thank you. Okay, so you said that we can basically ask Google to run a model and it's going to be trained. Is there any way that we can know what exactly the architecture of the model that it's using for predictions is? Because you said that we can use our own architecture or we can let Google do the task of training and then run our tests on it. But I didn't see anywhere where we could tell it to run, I don't know, certain architecture of a CNN or something like that. Is it just...
Yes, so Vertex AI, as I said, it has 3 ways to run jobs. Good. We are good. You asked that if you are able to see deep dive or see the model, how it was constructed in dive. For AutoML, where they offer this for you as a managed service, you are not able to do so. You control the artifacts. So if you add additional elements or if you measure something, you can create that variable and store as an artifact itself. But it's getting the AutoML model, it's getting, let's say, a bit custom model. The approach here that needs to be understood that if you have the objective in the AutoML choose list, go ahead, try it out. If you see that you need to go beyond, you need to, let's say, ditch this approach, and you need to build your custom model itself, like a BERT or a DNN or whatever layers you want to actually run for it. But that means that it's custom work. If you are in the custom work, and if you want to run that on the cloud, the Vertex AI system lets you to actually do this all there with pipeline and serverless and everything. You could also run it on your own CPU or on your own GPU or on your own, let's say, traditional VM, if you are able to set those operational. It's essentially, it's a platform as a service for machine learning jobs.
Okay, thank you.
Yeah.
Okay.
Thank you for being here.
We still have time for questions, if there are any more questions.
Yeah, essentially, if there is a question, let me know. So if you are able, let's switch to the screen. So this is the dataset screen. You are able to actually create here and choose what you want to, which objective you want to try out. I have here image object detection, for example, the one I had in the talk as well. So you upload images, you have an UI, for example, if I need to, this is not labeled, and hold on. Hold this mic.
Okay. Like this.
So that's a labeling job, and you have it there. And you can do also for this operation. Once you have this data set, you have this training tab where you are able to you name these data sets, you give them name, you set it, and you go continue, continue, and in the end you will have a job that runs for, I don't know, this was 25 minutes, this was 5 hours, 3 hours, so it depends on the volume of the data and the type of module. After that, you have the model itself. The model is just a list of it. Then you have Jupyter Notebook. It's offered for you. I now click, but it's not important what's in there. It's the pieces of code that I mentioned, that 10 lines of it. Essentially, you get the pipeline visually as well. And this is another of that. And for example, here I created a playground where I integrated the endpoints. And actually, if I click on this, it will be a bit slow because in machine learning, this is around 4 or 5 seconds, so don't expect like that. Here, the response is sunflower, the percentage is 100. Let's see for the dog, because that's out of the objectives. I mean, it was flowers. It predicted tulip. It's 89%. You may wonder why I show you this. In data science, you need to train garbage data as well, as an, let's say, outsider label. So you need that. Often people forget it. So you need to also train, you have input data that you can mark and label garbage. You can train as a garbage for that. Now, essentially, and this is my last sign, this is the code, but essentially, you have functions. You don't need to write too many things, just copy the tutorials. You have a function to get the predict, and here the input is actually the instance and parameter that you need to build out based on AutoML models. Then you get a response, and I actually printed this dictionary, what is one in there. So it's nothing complicated, just you need to put together in order to run all these steps for you. Thank you for being here. I answer next questions at the back. Thank you.
Okay. Thank you, Marton. Okay, so the next presenter. I'll just wait. Okay, so the next presenter will be